Welcome to the LemnaTec Academy. In this video, we will have a look into the final major section of LemnaExperiment, the vessel configuration editor. But why do we need another vessel configuration editor if we already have one in LemnaGrid? There are a couple of scenarios where it can be helpful. You may want to reuse a grid file for a different application. For instance, you created a grid for 4x6 well micro heater plates. But now you have an experiment with 2x3 well plates. Then you don't need to modify the grid. You can use just another vessel configuration. The vessel configuration editor of LemnaExperiment has some additional features like it supports hexagonal layouts of samples. It has an easy arrangement in rectangular and hexagonal grids, including tilted grids. You can create vessel configurations spanning multiple images if a vessel is not recorded into a single image. So you see there's a couple of scenarios where the vessel configuration editor of LemnaExperiment can be useful. So let's have a look at it. In order to get to the vessel configuration editor, we have to enter the vessel configuration page. Like in the analysis definition video, we start with a list of vessel configurations. If you start from scratch, this will be empty, but we have already added a few. Let's create another vessel configuration and press the Add New Vessel Configuration button. What we first see is a big error message and some additional hint text. As mentioned in a previous video, vessel configurations work only for a specific size and perspective of the image. If either is changed, this requires a new vessel configuration, here or in LemnaGrid. Different cameras may have different image sizes and perspective, and these might be changed further in some systems by the parameters in the recording configuration. Hence, strictly speaking, any vessel configuration shall work only for one recording configuration with one type of camera. However, you may have two cameras with the same perspective and image size, and two recording configurations may differ only in parameters which do not affect the perspective. So you may use the same vessel configuration for them, but you have to be careful in choosing them. And we have another point to consider. Most cameras have only one position over the vessel and record always the full vessel. However, some cameras in some settings record only a part of the vessel at a time. They need to take multiple images to cover the full vessel. Vessel configurations work only for cameras which have the same camera positions. We will talk about vessel configurations for cameras with multiple camera positions later in this video. But for now, we focus on cameras which record the complete vessel in one image. So we need to select one or more recording configurations and one or more cameras with consistent image size and perspective. Let's pick HDR acquisition at center. Because we have only one camera with this recording configuration, we have already resolved the issue with this error message. The all in the camera selection refers now to this camera only. Before we continue, let me give you an overview of this editor. On the left, we have a simplified version of the image browser we know from the recordings page. However, the selection of recording configuration cameras will become also part of the vessel configuration itself. At the bottom, we can select the images we like to use to determine our vessel configuration. If we click one, it became visible on the bottom left. More on this in a second. In the top center, we define the layout of the sample positions on our vessel. This includes how many positions we have, their basic arrangement, and how they are called. On the top right, we have an editor to define the positions of the samples in the image and the shape of these wells. You can enter numbers here, or you can use the image below and drag on the sample position markers. Let's select an image. You see this image, but it contains also 16 circles in red. These are the currently defined sample positions. But before we continue here, let's have a look on the layout section. We have three types of layouts. Rectangular, which is probably the one used most and the one you see right now. Hexagonal. Some plant trays have this kind of layout. Free. You can place and name the sample positions here freely. In the two other types, the positions are named A1 to D4 and so on. Here you can give each position its own name. But let's continue with the rectangular layout and check what we can configure in this case. First of all, how many rows and columns we have. In our example, this is 3 rows by 5 columns. We can define if the letter shall name rows or columns, and if the numbering shall be reversed for letters or numbers. In order to be compatible with Lemna grid layouts, the number part of the well name shall be start with a leading 0 if the number is smaller than 10. In hexagonal mode, we have a few more parameters. We can define if the first row is intended or the second row is intended. If all rows have the same length, or every other row shall be shorter by 1. And if the whole layout is transposed, the columns are shifted against each other rather than rows. Let's have a look on the right. Here we define the actual positions of the wells in the image. We have two modes. Assistant, where you define only 2 or 4 corners of the layout. And free, where you define the positions of each well individually. Let's start with Assistant. You can enter the position of the wells directly. Or you can drag them in the center of the wells. If you drag on the edges, you can change the size of the wells. The cursor will indicate if you are about to reposition the well or resize it. However, there are 2 more parameters which you can change up here. The offset between the rows this is only available for hexagonal layouts. And the roundness of the wells. A value of 1 means circular or elliptic. A value of 0 means square or rectangle. And a value of 2 means diamond shape. Let's go back to the rectangular layout and adjust the position and sizes. We use a roundness of 0.3 to mimic the roundness of the pots. As mentioned in the Lemna grid video about the vessel configurations, it is a good idea if the valves are a bit smaller than they are on the image. There's one more control we need to discuss. This changes the behavior of the dragging on the edges. In the current mode, it changes the size of the center of the valve such a way that only the edge you are dragging on is changed. However, in size-only mode, the center of the valve is unchanged and the edge is changed on either side. You may have noticed that the tray is not perfectly aligned with the image. We may handle this by selecting the well slightly smaller, as I described before. But we can also use the tilted mode. In this mode, we define all four corners of the layout and can therefore adjust for a tray which is tilted. Now we shall check if this layout works with other images as well. We can see that there is a bit of jitter in the positions of the tray itself. So let's choose a slightly smaller size for the welts. If we switch to free mode, we can select each well individually and change its size and position and roundness. Wells that have been defined in free mode are marked in green. Wells which are not yet defined are marked in blue, and the current well marked in blue with a green border. If we switch back to assistance mode, we will lose some of the positions we have defined and use the currently selected size and roundness for all wells. So, we have created a vessel configuration. The only thing left is to give it a proper name and press rename. If you have no camera with multiple camera positions, then you can skip to the end of the video. We will now discuss vessel configurations for this case. There are basically three scenarios to consider here. The split scenario. Consider a microtheater plate with 4x6 wells, and we are using some kind of telephoto camera which covers only 2x2 wells at a time. Then we can define a common layout with 4x6 wells, but each camera picks only one part of it. This mode is called split mode because it splits the layout into pieces. The wells are named as usual from A1 to D6. The repeating scenario. Consider some table where we placed 4 plant trays with 3x6 plants. We position the camera over each tray always in the same manner, so the plants are in any image at the same position. Therefore, we can repeat the layout at all camera positions. The name of the wells include now the camera position names. Here, C1 to C4. So we get well names from C1.A1 to C1.F3 for the first tray, and C4.A1 to C4.F3 for the last tray. The individual scenario. In this scenario, we have no systematics in the placement of the samples whatsoever. Consider, for example, we have 8 plant trays, each with 4x6 plants, but we have only 5 camera positions. So at each position we record more than 1 tray, but less than 2. Hence, we have to split this individually between the camera positions. the names of the valves are similar to the repeating case. However, since we have different amount of plants in each image, we may have names like C1A1 to C1F6, but C2A1 to C2D6, and so on. But how does this look like in the vessel configuration editor? First, I create a new vessel configuration and select a recording configuration which has multiple camera positions. The default layout mode is split layout across the camera positions, or short split. In these images here we have 4 tables with 8 trays each. Each tray has 4 by 6 plants. Let's focus on one table with 8 trays. Then we would have 32 rows by 6 columns. In the first image, we see 6 rows. So we have rows 1 to 6 and columns 1 to 6. Now we position the valves. Let's look at the second image. Here we have 9 rows, but the 2 top rows are already covered with the previous image. Therefore, we have the rows 7 to 13 and columns 1 to 6. However, in this case of these images, the split layout seems not to work well. Let's have a quick look on the repeating layout then. However, we need the final mode, the individual mode. If we change the layout geometry on one image in repeating mode, then it affects the images on all other camera positions as well. But not so in individual mode. If we select another position, the layout of this position is used. If we select a yet not used position, then the layout of the previous position is copied. Finally, we check if all positions have the correct layout. You can use the assistant mode to position your valves as we have done here in this video. However, in individual mode, it is quite likely that you prefer the free mode. Or you make an initial rough layout using assistant mode and do only the fine-tuning in free mode. One last remark. In LemnaExperiment 24.11, we introduced an experimental feature into this dialog, allowing partial vessel configurations. If this feature is enabled in the settings page, then you can create vessel configurations which include only a subset of camera positions. Please note that experimental features are not yet well tested, and that they may cause problems, in particular in the analysis. This was the last major part of LemnaExperiment related to the analysis process. In the next video, I will explain how to use LemnaExperiment to convert parameters measured in pixels into metric values, and why this might not always be a good idea. See you there.